Hello, welcome back to the video series. Today we have regression. I do want to say that if you have not watched the correlation video or you do not understand correlation, please watch that video. If you already understand correlation and know how to compute that, then regression would be the next step. So why do we do regression? Well, simple linear regression is used if we want to predict a person's score based on another score that we already have of them. So basically we have an X value that we've gotten for someone. In the correlation video we were looking at basically aggression and likability. So the idea is if we know what their aggression score is, then based on that relationship, the correlation that we've already calculated, we should be able to predict what their likability score is. So this gives us an idea in the real world. The other example that we had as a practice problem in the manual for correlation was the relationship between temperature and coffee sales. So imagine that you ran a coffee stand and you were trying to figure out how much coffee to buy on a day-to-day basis because you did not want to have too much stock at hand. Then ultimately, if there was a very strong relationship between temperature and coffee sales, then given that relationship, you could then on a day-to-day basis simply look at the temperature for tomorrow and then plug that into the regression equation, and that would give you an output in terms of how much coffee that you should buy on the next day. So what does the regression equation look at? As you see it over here, we have what I call y hat, but it is basically y predicted. This is the value of the dependent variable. And then we have equals bx plus a. B is the slope. It is the amount that y is predicted to increase for an increase of 1 in x. Then we also have the raw score, which is x, and then we have a, which is the y-intercept for the x variable. So as you look at this, if you've done other math, you may look at this and say, that seems very familiar. It's the equation for a line is essentially what it is. But we are going to apply it with our actual correlational data. So on the previous example, we had a correlation. We looked at the correlation between aggression, their aggression score, and their likability score. So, for example, if you have an aggression score of 5, then you might have a likability raw score of 6, or 1, you would have an aggression level, an aggression level of 1 and a likability score of 9. So notice in this instance that we have many of the values over here, but we don't have 2. So what would it be if you had an aggression score of 2? Or let's just say we know that one person that actually had 9 had an a likability score of 3, but what would the model predict that their score should actually be if they had that aggression level of 9? So as we move forward, how do we get to this? Well, ultimately we have to calculate the slope, which is the b variable in the equation. So notice that the formula for the b variable is the pooled variance divided by the sum of squares for x. Remember in the correlation video, we already did the pooled variance, and so we showed you how to do that. So as you calculate the sum of squares for the x value, we will need that, and so we're pulling this from the previous video as well as the toolbox. So as we move forward, we'll simply take 40.7, that pooled variance from the toolbox, and the sum of squares for x. We'll do simple division. We get a value of negative 0.832. So that gives us our slope, but we still have more to do. So the second step is we need to get that a value. And so as we look at the a variable, the formula for that, now that we have the b variable calculated, we simply add the mean of the y variable, in this case likability, that's the average likability score for this particular set of individuals, and what's the mean of the x variable, or what's the average of the aggression score for this particular set of individuals. So in the earlier videos we calculated that average aggression score is 5.1 and the average likability score as 5.7. So we then simply put all those into the equation and we come up with an a value of 9.943. So at this point, we have most of what we need for the regression equation. So as we said before, what would the model predict? Remember, we had one individual that actually had an aggression level of 9. That person's likability score actually happened to be 3, but what does the model predict? Well, if we insert 9 as the actual x variable, along with the b variable and the a variable that we calculated before, the model predicts that their likability score will be 2.455. So in this case, the actual person whose scores that we measured with a likability of 3 was actually slightly more likable than the model would have predicted. So I guess good for him, given that his aggression score is so high. But we also can basically use that equation to put the regression line onto the scatter plot of all of our variables. or the values that we actually collected. So think of the regression line in the scatter plot as a measure of central tendency. Just as the mean would cut through a distribution of numbers, in this case, that regression line will cut through, it will be the line of best fit for all of our values for the 10 individuals whose scores that we actually collected. So we have to basically end up drawing that scatter plot as you see it here, and we will take you step by step, but ultimately the x variable should be down here on the x-axis, so that will be aggression. Likability will be the y-axis, and then we'll have to plot the individual scores. So this is the actual data. We had one individual that had 5 and 6, so basically we go to the aggression score of 5 as we see it down here, and their likability score of 6, and then we trace those together to find where those meet up, and then that's where that dot goes. Similarly, we do the same thing for 6 and 4, 1 and 9, 8 and 2, 9 and 3, 5 and 7, 6 and 6, 4 and 6, 3 and 7, and then finally 4 and 7. And now we have the full scatter plot that I showed you before. So, how do we actually put the regression line in there? Well, any line simply needs 2 points. So the first point, we will simply say, what is our y-intercept? In other words, when does that line cross through the y-axis? And it does that at 0. When x is 0, the line will cut through the y-axis. So we take the regression equation that we calculated before, and we simply enter 0 in place of x, and that tells us where the line will cut through the y-axis, and so that predicted value is 9.943. So the first point for our line, we're going to draw right on that axis as this equation has given us. How do we get our second point? Well, our second point is by basically plotting the means of both aggression and likability. If you recall in the previous slides, our aggression average score was 5.1, our likability average score was 5.7. So by finding the intersect of 5.1 for aggression and 5.7 for likability, we get that second point on the line. Then all we have to do is connect those dots, and this is our line of best fit, or our regression line. So now, if we have the graph, even if we don't have the regression formula handily available, we can simply look at this line and say, okay, well, if somebody has an aggression score of 8, what's their predicted likability score going to be? So as we go up, we just look at where that line intersects with the aggression of 8, and that's going to cut through at about 3. So the line of best fit in terms of prediction for a value of 8 will be around 3, perhaps a little tiny bit higher than that. Thank you for spending your time with me during the video for regression, and that is pretty much the last for the correlation and regression pair of videos that we do. I appreciate your time, and I hope that this journey has helped you with your understanding of statistics.